Good morning. Thank you for being here. In the interest of time, we'll jump straight into this. Arun, we'll start with you. Would love to have you talk about yourself and what sort of made you gravitate towards space tech.
I think almost everybody who loves engineering has some exposure towards space tech sometime or other during their lives. And it was like a very natural pull. I did my PhD in areas that were related to space tech, and Iron Man movies came out during similar times. And if you are an engineer worth your salt, Tony Stark will kind of influence you to start building something related to space tech. So that was like a very, very natural pull into it. I'll keep it short like this.
Nitish, maybe you want to talk a little bit about just your journey, your background. And I know at some point you were involved in building a rover to go to the moon. So what got you directionally towards space tech and what got you to start Astrogate?
I think space tech was always in my mind right from my school years. So when I got the opportunity to get into IIT Kharagpur, I picked up aerospace engineering. Not to say like I could have got CS, but I was content with what I got. There I wanted to learn as much as possible. So most of the time I was mostly spending time outside the curriculum. We wanted to do a small satellite project, but that always remained in the books. Post that, I think during my third year, I came to know about this Google Lunar X Prize. Checked it there. It was basically a funded competition and was announced by the X Prize Foundations and all that. And came to know about a company called also Team Indus. So it seems exciting. I wanted to join them. Did a few on and off work with them. Later on, I joined them. So I have been in the space technology sector for almost 9 years. Graduated out in 2014. Worked at Team Indus for almost three and a half years, where it was a really exciting journey. And I think this was very early years of space tech in India as well. Not a lot of companies, a couple of 2-3 companies was there. There was also some regulatory hurdles, which I think over the last 4 to 5 years has already been coming up. So it's been an excellent journey from there. Then I wanted to do something of my own. And if you talk about space, as we are scaling space to, interplanetary, or right now we are in low Earth orbit, at least most of the commercial satellites in low Earth orbit, but we want to scale that beyond lunar distances and all. So you need at least every asset that you can imagine. You will have need for power, you will need to have propellant, you will have a need for communications as well. And communication is one area that I picked up because when I was working there, then the traditional radio frequencies was becoming very expensive. So we wanted to solve that. That's how we started Astrogate Labs. It has been a long journey for us, but we have already built the core technology that enables laser communications over longer distances, much more efficiently than what radio frequency can do. And now we are migrating towards, just going and qualifying these products, not just for the space, but also defense and other terrestrial use cases. So that's roughly it.
Thank you. Arun, we'll come to you. Why does InspeCity exist? What do you do? What problems are you solving?
Done. So maybe we can start with a video. Try to show what we do. But in general, if I start off, InspeCity is figuring out a way to make space sustainable. Right now, we are kind of sending up assets in space. In a way, humanity has mastered the way of launch. We have mastered the way of building satellites. We are sending these satellites way up there now. But there is no way for them to figure out a way what happens when they don't work, right? So we are kind of building them to be use and throw in some ways. And a lot of these are very high value assets of the order of hundreds of millions of dollars. So you can see a way of extending the lives of these satellites in a technological pathway or a technological vision, but in practicality, it is hard to do. You can imagine that a lot of technology needs to come together where you're trying to mate with something that is moving at about 7 kilometers per second, and then you're trying to reduce the relative velocities to 0 and then capture it. So here you can see step by step what we are trying to do in terms of building a robotic capture mechanism that is autonomous in nature. You cannot have a lot of ground intervention during that period. You need to have a propulsion system. Okay, that was not intended. But you need to have a propulsion stack that allows you to maneuver the satellites as you come close to another satellite. So all of these from the base, the propulsion systems, the robotics, the sensing systems are being built in-house in order to get integrated with the satellite that will make the ability for humanity to make space sustainable, right? And of course, capturing debris, building habitats in space are offshoots of what we do at the core level. So this is what InspeCity does.
Thank you, Arun. Nitish, I'm going to come back to you. I know you spoke about space communications in your introduction. Can you break down what does space communication mean and what does Astrogate solve for?
Yeah. So I think before going to space communication, I think I'll in general just spend time on communication in general. If you talk about the current terrestrial communication infrastructure, all the internet backbone and everything, that's basically almost all the data goes through your undersea optical fiber communications. Obviously, satellite internet and all that is coming in. But imagine now you have to expand this communication infrastructure out in space. We are not just Earth, it could be lunar, there could be assets around it, there could be surface assets, rovers and all. Push it to Mars and beyond. You need long-range communications that are much more efficient. So similar to what undersea optical fiber does, we want to extend it to Moon and Mars and all that. The only scalable way to do that would be adopting laser communications. So instead of it going through optical fiber, it's basically just point-to-point space communication. I'll also just want to highlight, we are not saying that radio frequency will be completely replaced. There are use cases where radio frequency excels. So if you want to talk about point-to-point communication, then even at your home, you will get basically optical fiber communication. And at your home, you will use a Wi-Fi. So where point-to-multipoint is needed, radio frequency is definitely going to be there. But if you want to have a very efficient way of communicating at long ranges, high speeds, and one more thing is security. So laser communications are typically the way to go. So that is what we saw the future coming in at terms of the space communication infrastructure. Laser communication has been tried, tested, mostly by space agencies. So NASA did it during, I think, around 2013 from moon distances, lunar distances. Now they are just doing it, far beyond the Mars distances. So if you have to communicate at that range, you don't need a 70-meter RF antennas. You can just do with a small 30-centimeter, like an amateur telescope that you can put at home. So that's the idea. It basically reduces the cost of total transmission. It increases the transmission bandwidth. It can also provide, almost all-time connectivity if the whole communication infrastructure has been built. So that was the general idea, and there have been challenges. Laser comm, if you talk this, imagine you have a laser pointer in hand and you want to point it over moon. I cannot keep it stable at a very small aperture. So those are some of the underlying technology we worked with, and we have already done that. We started working with defense. We have provided them the few use cases on this as well. So that's how we started. So space communication, if you are talking about building a space communication infrastructure, laser communication is one of the underlying technologies that needs to be there. So that's the idea.
Got it. Arun, I'm going to come to you. You did your master's at Penn State, rather your PhD at Penn State. I'm sure you had all the opportunity to stay there, do research or consult or build a company. What got you to come back to India, and what got you to think about building InspeCity from India for the world, as against building InspeCity from North America or wherever else?
So, very deep question. Not easy to answer in short, but I'll take a stab at it. So I imagine that, yes, we have all had and watched stories of Indians migrating to States or Europe and building a very good career out of that. NASA is actually, stacked with a lot of Indians. I looked at that, the way of doing things there and the way that, the West was kind of going into it. The key area that struck me is that the cost of technology development, a lot of that is tied to manpower in some way, other than the fact that you need hardware and you need software, but a lot of it goes towards the manpower side. And of course, there is a joy in building things where things are already in motion. There is a joy in joining a team that is already winning. But all of these put together, kind of drove me towards coming back towards India, where things were kind of getting started off in the space tech area. Things were hard to do, and I'm always pulled towards things that are very hard to do. The ecosystem was being set together by, I would say kids like Nitish, right? They were putting their heart and soul into doing this. We could watch it from afar. And as I was part of IIT Bombay, I'm a professor there still, I watched them put their heart and soul. There is a company called Manastu that came out of my lab. As I watched all of these, I realized that there has to be more and more push towards doing product development along with R&D, right? And that is what pushed me towards creating a much bigger vision that normally would be harder to pick up and execute that step by step. And very happy to report that Vishesh was with me from day one in some way as I came out. And it has been a very, very good journey ever since. Right.
Nitish, let's talk about Astrogate. And Astrogate's not necessarily building a product just for India, right? It's building a global product. And how are you thinking about building something from India for the globe? And in that journey, how have you been collaborating with Indian institutions like DRDO and ISRO?
So, yeah, getting this obviously has been hard. It's a long journey to develop some core tech. So space, if you look at it, the commercial infrastructure, at least in low Earth orbit, is sort of already getting monetized. So there are use cases that you can directly serve. Those have already been done. So you can serve those use cases. Let's say, mostly Earth observation constellation generating a lot of data. So you can provide very high speed over 10x, 100 times data return with lasercom. But this also basically moves the frontier forward. So if you can adopt it more than LEO, the geostationary and beyond, then you will be able to open more of the market. But obviously that's a longer term thing. So when we started building this India, I think always in the back, we wanted to build this technology core in India itself, because we saw a value in the tech itself, because not just it can serve the current use cases, but it can take this, as I said, the more frontier forward. It can be adopted to many use cases. Obviously, space tech takes a bit of time. Our technology, then we started looking at whether, before space, is there any other use case that we can serve? So one of the key fundamental advantage that lasercom itself provides is security. So we started exploring stuff where we can do it for, the defense forces in India. We got one opportunity to work with alongside the Navy, VESI. So we are basically providing laser communication starting from just terrestrial. You can do terrestrial fixed communication, maybe extend connectivity to remote areas. But where we outshine is basically making laser communication or enabling it over mobile platforms. That's what is the idea. If you want to just do point to point, you can just manually fix it and keep it stable. But if there's are moving targets, that's where more of our technology shines. So this is a basically ship-to-ship laser comms, and later on can be adopted to air-to-ground. What we are also seeing what's happening globally is right now, I would say after the Russia, Ukraine, and all those conflict, there are key technologies that are being emerging. In fact, a lot of NATO fundings also is going into key technologies, and one of them is laser comm. They're looking at ship-to-ship. We're also seeing, in laser comm anyways, there are not a lot of players doing core fundamental research, like enabling the underlying pointing and tracking system, modems, and all that. So there are like 4 or 5 companies doing that. So we wanted to build that right, for the global economy as well. So having this underlying technology with us, it gets us, we can collaborate with different partners outside to provide them these solutions for the ultimate user out there. So that's how we started doing it. Also, as this is a new technology, you need partners and collaborate with them to establish, cross compatibility. So there are research organizations in Australia. They're doing a lot of optical ground station research, and they have invested a lot in making optical ground stations. So if we are doing a laser communication that can send data to ground, having that collaboration and basically validating that those ground stations can be used, our terminals can communicate with those ground stations, but maybe our future ground stations as well, that basically puts the narrative forward, and it actually makes the end user in any of the Earth observation constellations or other guys that the technology and all the solutions upfront are ready to adopt it. So that's how we were thinking about it. And where we are right now, I think we are able to come and monetize on those solutions. Yeah.
Thank you, Nitish. Arin, I mean, we're all fundraising, and when you're out there trying to fundraise, the thing that gets thrown at us is, oh, space tech is capital intensive. It takes a long gestation period to make revenues. How do you think about building InspeCity, and how are you thinking about breaking this myth?
No, that's definitely a hard myth to break. It cannot be done by telling. It has to be done by showing, right? And I touch back upon one of the points that I said earlier, where manpower is incredibly expensive across the world, especially in deep tech. And when you say space tech, it is deep tech, right? So let's say you have a project of the order of $100 million, right? And you're trying to develop a technology of that order. The manpower cost would be around 50% of that, right? Across the world. Just for the record, let's say 3 days back, there is an Italian company called D-Orbit that got a contract for something that I showed you earlier to do life extension for satellites for European Space Agency, or ESA. The contract value was $120 million. Before this, they have already got a contract of around $250 million from the Italian Space Agency. So to do this fifth vertical in space, other than launch and ground stations, satellite manufacturing, Earth observations, SATCOM, and the fifth vertical is ISAM, which is in-space servicing, assembly, and manufacturing. It is imagined that other than these, this is an extremely capital-intensive vertical, right? The capital is primarily reserved for manpower. And that is where I think the India story comes in very, very well, where we are sitting at a place where we are brimming with human capital, with extremely talented people who are getting pulled out into the world because they don't have anything fun to do. And space, I repeat again, is something that excites every one of us to the core. The way that the country came together after the Chandrayaan-3 mission should be, some sort of a testament to that theory. So any engineer who was going to go out or was going to do a job in, no offense, in let's say Ola Electric, right, who has gone public, I can say that, hey, you're going to build robotic arms for space or batteries for space. And immediately, for space is such a nice keyword that it pulls people back. And people don't even want money in some way, which is a good thing. But we can pay them well still and undercut the entire world in terms of development cost. The rest of the cost goes towards building hardware, right? And I think Indians have mastered, with ISRO behind us, the way of doing things with very little capital. That's very, very a strong fact. The cost of the Mars mission was less than the cost of making the movie The Martian. At multiple proof points, it is there that we can build things at an infrastructure level that are far less cheap compared to the entire world. So I think because space has no boundaries, the way of building things out of India for space, for the entire world, is a very, very pertinent theory. And it has to be proven out again and again.
I think it's also fair to say that the IDEX programs and some of them are also becoming methods of getting early financing or NRE financing to prove some of the tech. And I know both of you work very closely on.
Definitely. I think the platforms are so clean nowadays. They are very, very open-ended. They're very, very transparent. The milestones are very well laid out. It's awesome. I hope the Make One category, which gives up to around $30 million plus in funding, also is like that. It is going towards that direction, but government putting in $30 million is going to come with its own challenges. Government putting in about $2.5 million is still okay, right? So,
good. I think I'll come to closing questions with both of you. Arin, the truth behind the name for InspeCity was that you have a vision for building cities in space. So let's just talk big vision, leave commercialization, leave funding out for a moment. Big vision, what is it to build cities in space versus going to Mars? And where is your views on that?
I believe very strongly that we need to stay closer to Earth. I don't believe in putting up human habitats in Moon or in Mars. We should have this conference up there floating up where gravity is reality because of rotating bodies. We'll just go step by step towards it, right?
And Nitish, your views, I know you were building rovers for the moon. So what's your thoughts on deep space and going to the moon, going to the Mars, or being somewhere in between here and there?
Yeah, I think it's a lot has changed over the years. So first is if you're talking about space tech, there are frontier technology that needs to be moved forward. The last manned moon missions was, done like 50, 60 years back. Now, if you see the news, a lot of go back to the moon is already there. There are a lot of landers, already private companies are doing that and they have been successful. So those areas or venues are already opening up to start utilizing that technology. Obviously, in order to first do that, the proving of the technology has to be there. So a lot of technology has to be proven there before we start more commercial adoption takes place there. So right now, where most commercial adoptions are there is obviously in low Earth orbit. So the technologies that, if there is a technology that can serve almost all the purposes, I think that's the way to grow the business as well as the tech and push this forward. I see, maybe in the next 10, 20 years, we will be able to do much more commercial missions out there in moon and beyond, definitely, I think.
I just
You have
have one thing to kind of conclude from my side. I don't know if the investor community is watching, but Vishesh is becoming like director Nick Fury. If you watch the Avengers series, the guy with the eye patch who kind of orchestrates everything, I imagine Nitish is like Hawkeye, who shoots very well, very accurately. I would imagine I'm like Iron Man, or me and Tausif together like Iron Man. I'm trying to understand who is Hulk and who is, Black Widow, et cetera, in the community. Yeah.
Working on them. But guys, thank you very much. Thanks for being here with us, and thank you, NASCOM. Have a good day.
Thank you.
Thank you. Thank you for having us.